So next one is marching cubes. It's algorithm where we take this, for example, at the end of slam, we will have this slam and TSDF function. We will have some volume, voxels volume with some data, and we need to take the data and create some 3D model. That's where marching cubes arrives. So you can see, for example, here with different, it's the same shape, but with different grid size, as I already said. Grid size really matters. And you can see that different grid size depends on how many vertices, or in this case, faces we have. So here we have 70 faces, and here we have 27,000 faces. And the shape really differs. But all they are made using the same marching cubes algorithm. And this one is the scan of the person. So to start, let's go through the marching squares, which are which are 2D versions of marching cubes. So assume we have this map with like 5 by 5 with all these numbers. First one is threshold with some ISO value. For example, let's take 1.5. It means that all what is bigger than 1.5 become 1, what is less becomes 0. So you already have it. Then we convert binary image to cell. So we take all this set of 4. Oh, not yet. So in this case, we just make 0 as black and white as 1. Then we calculate for this each square. We calculate these numbers depending on what are black points, and then we put these numbers into these squares. Then we look up the contour lines. We already have this table, and depending on case, we can draw the line. Here you can see this. And last one, we just look at original values and use linear interpolation. So it means that between 1 and 2, it's more like closer to 2. Between 1 and 3, it's more closer to 1, and so on. And that's how we convert this not round shape, but more straight shape to this round shape. And the same is marching cubes, but in 3D. So generally it's like 2 by 8, it's 256 combinations, but it's just 15 unique, and you can see all of them on the screen. So they are 15 unique combinations. All other, it's like mirror, rotation, or reflection of these cases. And let's take a look on the marching cubes algorithm. So we have these edges, we have 12 of them. We have vertices, we have 8 of them. And we have some vertex, 1. We already have the edge table and triangle table. They are already predefined for this algorithm. First of all, we calculate the mask. So in our case, we have only 3, which is outside. So it means that 0, 1, 1, 2, 3. And this third bit we make with 1. Then we take the edge from edge table, we take the mask. And in our case, the edge mask is 2, 3, 11. So it means that we have 2nd, 3rd, and 11th. So it shows us, here we know that we have only vertex 3 outside, for example. And this how we can say that the vertex is on the edges 2, edge 3, and edge 11. So these 3 points, and they produce a single triangle. Then we calculate points. Using these points, we should calculate this one. Using, by the way, the same ISO value, we compare this ISO value, and it depends. For example, you can see between 0 and 3, that point can be on 0 or on 3 or somewhere between. And this between depends on the ISO value. And here we create triangles from this triangles table, which also pre-calculated. And at this point, let me show you demo. So here is the first one. It's single cube demo. That's what we just discussed. So we have 8 edges, and whenever I click on some edge, we can see what exact it builds. So we can show two-sided mesh, for example. We can turn off cube itself. So in each single cube, what we have in our model, depending on which not edges, corners, which corners are inside, which corners are outside, it all depends on the size and form of this so it's basically how it works inside a single cube.